thank you so much for attending to my talk. We know there's still people coming up, so let's see the time. Now it's 50, so I think that we're good to go. So this is easy Java integration testing with Testcontainers, or how to simplify integration testing for enterprise Java, which is a big topic nowadays. And allow me to introduce myself. I had a talk yesterday, but for those who weren't that talk or haven't spoken to me yet, I'm Fabio Turizo. I'm Service Manager at Payara Services Limited. We are an UK-based company that supports and maintains the Payara platform in both community and enterprise editions. I'm based on Colombia. Nice to be here. First time in Chicago. I already tried the pizza. Yes, that pizza is big. So you can also find me on Twitter. I'm Fab Turizo. I don't tweet that much, but I follow a lot of people here on many places and technologies and companies and whatever. So feel free to plug me in if you want. So let's do some self-promotion. So Payara Services, it's a strategic member of the Eclipse Foundation. We implement and support both Jakarta AI and MicroProfile, which are technologies you probably know about if you work with Oran Jo's talk a while back. I think it was 2 hours ago. And he was using Payara as a way to showcase some of the technology changes that come on Jakarta AI 10, but mainly are certified on Jakarta AI 9 at the moment. We're still getting on our certification on 10. We already completed on the current alpha version that we're running. Hopefully, MicroProfile 5, which is the newest implementation of MicroProfile, will come soon. And we're also part of the Eclipse Foundation as solutions members. We contribute on behalf of our customers and our community on changes that we'd like to implement or technologies that we'd like to follow, or just in general, making sure that their voices are heard from the community. Payara Platform Enterprise is the product that we use in order to support companies that require strong coverage, let's say on critical mission-critical production systems. If they have an issue, they call our support line, they will get an engineer within an hour, the usual work on support coverage. And we also have a community edition, which is fully open source. You can download the code, you can build it yourself. It's free of charge in production and development. If you want to start developing on Jakarta and MicroProfile, absolutely, download it, start implementing applications on it. We have official Docker images that are completely free of charge as well, published on Docker Hub, that anyone can use if they want to use Payara on a Docker container. And you are very much encouraged to do so because that's what we are covering on this talk. Once your project starts scaling up and you are working on a big company and you see a source of, let's say, concern of, I would like support, I would like people to, or engineers to help me on my projects, then you can jump ship from community to enterprise. Pretty easy thing to do. It shouldn't be that difficult, and we will be there to support you on the entire journey. So let's get to it. The important thing about integration testing, which is a level about basic unit testing, is that you have to test multiple parts of an application software or a complete software. If you develop solutions for a company, the solutions will probably use a persistent store, a database, a file system, NoSQL or relational database, or you can even be creative and implement a solution using S3 buckets on Amazon or whatever cloud provider you use. Services do not live in a bubble. They need components to interact with. Now, I was talking yesterday about identity solutions, and an identity solution or provider is also another component that you need to test. So what do you do in these cases when you ship software and you need to test all of these components in separate? It's hard to do because you will have to either create extra services or create extra environments where you maintain copies of these products or softwares that you use, a production and test instances of a database or a service that you use, and you have to plug it in whenever you want to run the test, and only when you want to run the test. The goal of integration testing is to expose flaws in interface design. It's not necessarily to see if a piece of code is doing what it's doing. That's what basic unit testing is for. The point of integration testing is to making sure that, hey, I implemented a business rule that should make sure that a user can be created with this data. Oh, you did that. Yes, I didn't find that. Why? Because you didn't write the proper integration test at the stage that you needed to do so. And as well, you have to test all of the dependencies. If, for example, at some point your software that uses a database If that database gets upgraded and the current JDBC driver that you're using to connect to that database doesn't support that new version, then the whole thing comes down and you are unable to do something. You will have to upgrade the driver, and if the driver doesn't support your current code, then you have to go and upgrade your code as well. So it literally it's a domino effect. And you would cut that down early if you did proper integration testing to making sure, oh, now that I'm using this new version of the database, I now need see what the dependency has to be updated to. And integration testing is highly dependable on the platform. So if we're talking about Java, JUnit, TestNG, Spokes are the usual suspects when you write integration tests. The idea is that they're pretty simple to use, have a lot of documentation, and are highly integratable with any existing technology nowadays. However, for integration testing, especially if you want to test a database or if you want to integrate with another technology, then you will have to see the API for that specific product to see what can you do on the Java code itself, because that's the end point. Write some code that you can store in a source code system, at some point run it and making sure that everything works. There is also the fact that you can mock test. Technically, a mock is just simply emulating what would happen in a real world scenario. I don't like mocking in itself because it's good to simulate interactions if you're writing code quickly, and then you can just simply say, okay, did I write correctly my code? Yes, a mock will show you that. But on the real world, when something needs to go somewhere and data needs to be transferred from the end user to a database, that's not a real solution. You don't know until someone tries and someone hits an error that probably costs you money. So that's something that you never want to see. And then that fits into the works in my machine problem. Oh, I tested something. Oh, it's all good. I'll submit a PR. Wait, it's breaking? Why is it breaking? Oh, I didn't know that. Why did I know that? Oh, I didn't write a test on it. Well, I didn't want to write a test because I didn't have a database at hand. See, then it fits on exactly the same situation when you avoiding tests that actually are useful and actually saving you the trouble to do so. Because again, yes, software, as the word says, it's malleable, it's ever-changing, but we never want to pester customers with sudden unexpected errors that we could have prevented. And on the Jakarta microprofile work, we have a lot of challenges to do so. We don't have the proper tools to do this. Now that Jakarta E10 has come along, maybe we can start working on a testing specification. That's something in my wish list. Hopefully that's something that Jakarta E committee can start maybe taking a look at, a microprofile as well. But in the meantime, we do not have a specific testing framework to say, here is a Jakarta E software or a Jakarta E certified product. This is how you write tests to make sure that it works. Unfortunately, we don't have that because Spring Boot has been getting absolutely better at that part. They're getting us beat. The testing software is absolutely great. I don't have any downsides to say to that. But here is where Testcontainers can help. And the problem is that complex environments have lots of dependencies. Before, it was just simply the middleware and the database. Nowadays, that's usually not the case. You have multiple, and especially if you're talking about microservices, you have multiple parts, services that you have to test in conjunction in order to make sure that a single use case works. And the bigger the microservice stack, the bigger the test will be. And this fits into not cloud-native applications, because if they're running on a cloud, now you have another factor to lay in the whole, let's say, situation. The Archelian framework was a solution created a while back. Some of you may know it, some of you may not. It was a project created by Red Hat as part of the bigger JBoss project in order to test Jakarta dependencies in a vendor-agnostic way. Technically, you could grab Payara and run tests for Payara. You can run tests for WetSphere or Liberty or JBoss, Wildfly, or the enterprise application server. And technically, the only thing that you need to do was to supply an adapter for that specific vendor, and voila, you could write tests in a technically vendor-agnostic way. However, the problem with Archelian, and here is an example, is that in order to test something, you have to create a deployment. That deployment is not the actual application. It's just a simple package of the components that you want to test as part of that integration test. It's not the whole thing. It's just a subset, like a view, a personalized view of that component that you want to test just for the extent of the test itself. And when you do this, you can find into the problems or, oh, okay, I want to test the persistence layer of my application. Let's say that I have a method saying, I want to get all of the persons in an application. So you create a DAO object, and then it has a method that allows you to get all persons. But in order to test this, you will back away and fall into the same pretense of, oh, I can have a real database for this test. Because again, you're just simply creating a view. So if I don't have a database, how do I make sure that this test actually works? Let's create some sample data and mock it in a way that, okay, if I am returning data, I'm seeing the data that technically I would have if I executed this code in real time. But again, it's not a complete solution because you have to create a specific code in order to plug in the gaps. You're not testing something in real time, you're not testing the actual application, you're just simply creating a backbone and a skeleton of how the test should behave in a controlled manner. But the problem with control manners is that they do not test the entropy of the entire thing. Something could fail that you're not seeing, and that's perfectly fine. So, as I was saying, this will fall into a situation of you just assemble a part of the application to test it. You don't have the entire thing. You're not testing the entire thing. This includes code and resources because there is a perfectly understandable problem that code will transition stage. It starts in development, it has some properties and configuration specific to that. It will go to a testing environment, it will go to a staging environment, possibly to a user acceptance testing environment, and finally into production. So these transitions that require their own configuration are not included in that part of this test. You're ignoring all of that. Persistence layer is usually tested, but you do not test the store. And a common issue nowadays is whenever a vendor says, when a company says, we don't have the budget to keep paying X company this amount of money for our database. We need to cut down costs. Okay, let's explore our vendors. They never go immediately to the test. They never go immediately to test the database. They just simply see, we need to short down costs, we need to test, we need to replace the solution with something that is more adequate to our budget. Let's see it. An integration test would help solve that issue because once you do that, how do you make sure that your entire application software works like it should by swapping the vendor? You don't know until you find an issue on the software itself. And there is no way to test different configurations. So in a sense, you are not doing real world tests. You're just doing control tests that will work as you expect them to do so, but this is not really testing the thing that you want to do. So test containers comes to the rescue in a sense because it is a way to do lightweight unit testing. You are not preparing an environment to do a test. You're just simply creating a test environment within the test itself. The technology is based on Docker containers. How many of you use Docker on a daily basis? Let's say that, I want to test a database. Let's start a Docker container. Oh, it works. Let's kill it. How many of you do that? Okay, some people. That's exactly the same philosophy on test containers. You create a container, deploy your app, test it. It works, cool. It doesn't, cool, no matter. I'll kill the container, move on. And the intention is that it also is up the networking setup because this is extremely important. Applications and their components do not live necessarily on the same machine. They can live on multiple hosts in a different network topology. How do you test that? Usually. So again, let's assume that you may work for a company that has an Amazon development environment, and they may give you an account or a workspace, how it's called in Amazon. And okay, you can quickly create a database on the service that Amazon brings, test them, kill them, okay, that works. But if you don't have that luxury, how do you quickly test that on your machine? You will go to virtualize these machines, set up a network, and all of that. It's too much work for just running a simple integration test. Oh, sorry, I jumped right straight to the end. Okay, so the important thing about the benefits of test containers is that it brings effective black box testing. You are testing your software, it works, move on. You are not interested in how the container is set up because that depends on the technology itself. You are only concerned that your application works in that environment. The tests are user-focused. Instead of testing the technology, you are making sure that the tests emulate the real work environment of the user. Oh, the user wants to test this, provide the data, what do you get, an error or not? Okay. It's possible to also audit security standards doing this. If, for example, some of you work for a company and they're interested in making sure it's X dependency vulnerable, nowadays you can just simply create an integration test and try to create a penetration test to make sure, does it breach? Are you actually seeing sensitive information or not? In a quicker way than just simply running an auditing software. And you can also expose flaws in specific technologies. If a database introduces an error in a specific version, the integration test should tell you that. Again, why do I keep jumping to the end? Sorry. There we go. So the requirements of test containers are very simple. You only need Docker. At the moment, it only supports Linux containers. You can run those on Linux, Windows, and Mac. If you want to run Windows Server containers, because maybe you have done a specific need, at the moment that is not available for, but mainly all 90% of the use cases for enterprise Java are very much okay with Linux containers only. It supports JUnit 4, JUnit 5. You should be using JUnit 5 nowadays, and Spock as well. It has Maven and Gradle dependencies. The only thing that you need to do on Maven is to add the dependencies for the JUnit engine that you want to use. In this case, on a demo that I'll show, I'm using 5. And the dependencies for test containers. So you have to provide one for the dependency itself and one for the JUnit 5 engine. And that's it. At the moment, the guys are running on, the current version is 1.17.3. Now, how do you create a test container? Simple. On your test suite class, you annotate that class with test containers. It will plug everything for you. And then you will create a container for the Docker container that will host your application. In this case, and as an example, I am using a sample Docker image that I named Turizo, my app. This is supposedly an image that I built myself, that is on my machine. Again, not a real world example, but for the purposes of the demonstration works. And I'm using that to start an application. And since this is Docker we're talking about, you have to expose ports in order to consume that application in some way. So I'm exposing ports 8080, 1909, and 28080, which are standard ports that I use for either HTTP communication or Java debugging. And then I run a command. That's it. That's a container running. And the simple test I could do is making sure that my container is running. So at some point, my container will start, and I will see data, and I can interact with it. So we have to be careful, because the point of deploying a container is that a container has a life cycle. It will start, and once it starts, it will start doing everything on the layers defined by that container. So if you are deploying an application or running something or preparing a data set for a database, you don't know specifically when that is happening. So you need to be ready, because the test will run immediately after the container has reported started. But again, the container starts and it can be doing things on the background. So you have to wait for something. And in order to wait for something, containers have this method called waiting for that instructs you to tell the test engine to wait until the container is effectively ready. And for microservices and HTTP applications, the easiest way is to ping an endpoint. Oh, when this, my app, ready endpoint, it's, well, replying with an 200 OK status code, I'm good. It means that my application was deployed, I can start running my tests. And what test containers does is ping that endpoint in a configurable manner. It can do so every 10 seconds or so, and okay, now it's good to go. You can start running your tests. So you can also wait for a log message. If, for example, you're testing something that doesn't contain or expose ports. So if, for example, you're running a database or a service itself that doesn't expose something particularly user-friendly to communicate with, you can just simply proc for a log message on the container. Remember, the rule of Docker containers is that critical log events should always go to the standard output and be printed to the containers log. So you simply can say, oh, I want to wait for an application is ready. And you can use regular expressions that you contain and wait for, or to instruct the container to know when the application is ready to do so. Now, dependencies are another matter, because again, containers are not tested in isolation. You need to test a container and its dependencies. So let's say, for example, that you want to create a container for a database. And in this example, I'm using MySQL version 8. So the MySQL Docker container instructs you, if you want to create a container, use these environmental variables in order to configure the root password, the test, the password of that, sorry, the username of the user that it's going to connect to this database, its password, and the name of the database. Pretty simple. You just simply provide some parameters that you want to use. But remember, containers, whenever they are started, they are not visible to each other. You have to tell them where to find each other, and you have to put them on a network. And the Test Containers API allows you to do so with the weak network method. You just create a network like that, It's pretty simple to do. It's just a static build factory method. Put the container on a network and give it an alias. And that alias will be used as a host name for that container, so other containers can find them, like this. Now let's say that I want to go back to my application and say, my application connects to that database. So I have to supply an environment variable. Remember, on Docker, environment variables and system properties are the usual way to configure things, and you should always consider that applications will live in an environment where they are configurable like that. You provide just simply the server alias. And you have to put that container on that same network. Since this is Docker we're talking about, you have to specify some order. You don't want your application to start before the database, because once it tries to connect, the database is not ready, so it will fail. So you use the depends on method to tell them, oh, start the database first, and then start the container once it's ready. And again, you specify how you want a container to be ready for the dependencies in that order. Testcontainers, however, doesn't stop with that. It provides, let's say, a simplified database support. So there are special objects for wrapped containers. Popular solutions in the market include MySQL, MariaDB, Oracle Express Edition, DB2, Postgres. If you're using NoSQL, there's Couchbase, Cassandra, OrientDB, MongoDB, etc. And they're easy to instantiate. To do that, you only need to provide the dependency of whatever specific test container you want for your database. And you have to provide, of course, the JDBC driver. Absolutely, you need that in order to connect your database. And then you create the object with just the API itself. So Testcontainers API contains this MySQL container, which is just simply using you have to provide the MySQL official image name, if in the case that you're not using that. If you're using a customized MySQL image, you can also provide that. And you just simply say, oh, it lives on a network and it has an alias. That's it. I'm not bothering to supply credentials, no username, nor anything, because I don't care. It's a test. Why would I bother with specific credentials and configuration that I'm not going to care about in 5 minutes after the test is done? And to use this container, because again, we do need that data in order to connect to it, you can just simply obtain it from the API itself. So once I'm configuring my application container, I will pass the user using the getUser method, the password, and the database name. And I don't care what random generated strings did the Testcontainer API use. I just don't care about that. Remember, I'm just testing. It has to be simple for me to just simply run the thing immediately. You can also use this. If, for example, you want to test or want to run a simplified JDBC test, again, that test container, you can just use the JDBC API. So you obtain a connection object, and you just simply pass over the JDBC URL from the MySQL container, the username and the password. I haven't supplied anything. The container allows, or the MySQL test container API allows me to do that seamlessly. Then I create a statement, execute a query if I want to run a simple test, making sure that the database is properly set up and the tables and all of that is fine, and that's it. I'm done. I close the connection, and once the container or once the test is done, the test container itself will be stopped immediately. Docker is a very extensive software, and it has a lot of features. I'm not going to talk about all of them in this presentation, but the idea is that you can also use Docker Compose if you want to go creative and establishing a big architecture. For example, if your tests are really comprehensive and you don't want to code all of that, you can also use a Docker Compose YAML file and establish all of the testing infrastructure in one go. The only thing that you need to give to the Testcontainers engine is just a file path to your YAML Docker Compose definition file, and it will set up everything for you. It will use the names established in the dependencies. Docker Compose allows you to create a network by itself, so it literally saves you the trouble of, for example, setting 15 containers for one simple test. There are also popular solutions. Again, the MySQL and database integration API is not the only thing that Testcontainers bring. There are also official API objects for Elasticsearch, Apache Kafka, RabbitMQ, Solr, engines, and etc. Of course, not every software will have their API because some solutions are more popular than others, but most of the things that people know do or create on, let's say, solutions on the cloud are covered by Testcontainers itself. So we'll keep doing that. Don't worry, we are almost there. But this is not a silver bullet. And Testcontainers has some caveats. The first one is this extra layer of processing. Docker, it's let's say it spends a lot of resources. This machine only has 8 gigabytes and 4 CPU core. It's not powerful enough to run even the test that I'm going to run in a bit. But again, this is integration tests we're talking about. If you are working on a company, integration tests are meant to be run as part of the CI or CD pipeline. You have to provide appropriate resources and appropriate computing power for your test to give you the actual results. Maybe if you have a power machine at home, you can also run tests sequentially to making sure that they are working well. But again, this extra, let's say, computing power, it's a requirement. It's not something that should cover every basic need. Test time will increase because, again, you have to start a Docker engine, then the Docker container, then deploy the app, test it all, and kill it, and that will increase the test time. But if that is negligible for your, let's say, investment in making sure that the test actually works, and you are saving time later by catching errors earlier, that's an investment that will certainly be returned to you. And middleware must be prepared for Docker. Not everything has a Docker container nowadays, but technically everything does has a Docker container nowadays. But if in the rare case that you're using a dependency that doesn't have a Docker container official image, then, well, you can prepare your own Docker image. Again, I wouldn't recommend that because in the long run, you will be supporting a solution of your own making. So if you don't do it on the right way, you might be shooting yourself in the foot. So do not consider that solution unless strictly necessary. Always opt out for official images because that's what companies are tasked to do, making sure that Docker itself and the software that you are running in the container play well. If not, then that's a big risk. Black box testing is not suited for all software. Sometimes you want to see what happens on the background. If you're doing debugging, or if you want to run an integration test to making sure that all steps are properly executed, perhaps this is not the best solution. But those are rare cases that you have to consider. There's also a solution that the guys at Atomic Jar have implemented. Atomic Jar is the company that manages test containers. It's called Testcontainers Cloud. I will use it for the demo. You can talk to Oleg back there in the background. Oleg, say hi. He has a talk tomorrow about test containers as well. He will probably tell you more about the technology. But it's really, really cool. Okay, so demo. I have a demo on my official GitHub account. It's fully functional. You can run it on your machine just with a local Docker container. So let me show you then. Give me a second. So I have this application here that is composed of 3 microservices. It is, if you were in my talk yesterday, it's exactly the same application, a conference management application, composed of 3 microservices, one that handles sessions, one that handles speakers, and one that handles votes or ratings that you can give to each session. The intention is that each service is incrementally dependent on each other. The speaker service doesn't depend on anything. The session service depends on the speaker service, and the vote service depends on the session service. That depends on the speaker service. So if I want to test the vote service, I need all 3 of them. If I want to test the session service, I need only 2 of them. So that will factor into the test that I will show you in a bit. On the configuration of this test, these applications are Jakarta applications. Let me open one, for example. It contains Jakarta services, REST services, defined with standard Jakarta annotations. For example, I have one in here that obtains a speaker, obtains the data of a speaker based on its ID, and then returns data based on what is on the database. The services themselves are configured to use the embedded database that they bring. However, one of the services, the vote service, uses a MySQL database as its backbone. So allow me to show you here. On the application definition, I have a data source definition that, as you can see, uses environment variables to configure the data source that I will access to. And these variables will be provided on the integration test itself when I am creating the Docker containers. So let's go to the containers themselves and see how they are created. To simplify this, because I didn't want each service to have a separate service and then run it by separately, everything is on a separate module called combined test module. It runs after everything has been compiled and packaged for simplicity. And it contains 3 classes, 1 test suite for each service. So let's open the simplest one, speaker service test. And let's run it because, again, this machine is not that powerful, so it will probably take some time to compile this. And actually, I need to start Docker desktop. So let's give it a few minutes. How am I creating the container? I'm creating a speaker service container. It extends from generic container, and I pass over the image that I'm using in here, which is the Payara Micro official image. Payara Micro is a specific distribution of the Payara platform that is just a jar file that you run from the command line. Give it an application WAR file to deploy, and it launches immediately. So these micro images use the current existing community edition of Payara Micro, which is 2022, release 3, which was released last month, and it uses JDK 17, which is the currently support LTS release of Java. That's it. I'm only simply giving it an image name. That's the only thing that I need to create my container. How do I configure it? Well, let's say I want to expose the HTTP port. I extended this on this utility class as a public constant, 8080, the standard Java HTTP port. Then, in order to deploy my application, I grab the WAR file. In this case, this is the microservice speaker WAR file. I grab the path and I pass it over to the container with this command called with copy to file to container. In Docker terms, this is a Docker CP command. It will pass over the WAR file to the container and map it internally. And Payara Micro will expect all WAR files on this standard path. That's it. The only thing that I need to do is give it this WAR file in this deployment, and when the container starts, it will grab that WAR file and deploy it automatically. Then I have to wait for something. I have to wait for the container to be ready once I start my tests. And what I wait for is for this application.waddle endpoint to be available. And some of you will ask, Waddle? Isn't that the old thing that tried to standardize documentation of REST services and failed miserably? Yes. We support it still. It's a nice endpoint. We leave it there because it functions as a sort of ping to an application that you want to deploy. You can also ping a specific endpoint of your application services that you're deploying, but this is easier. I don't have to worry about any specific endpoints. Or if your application uses OpenAPI, that is also an option as well. You can just simply point the OpenAPI endpoint, and if it returns OK, then you know that your application is deployed successfully. And then I start my container. I deploy the application. I give it a context root. Why I'm deploying like this? Because I just doing this to showcase that I can override the deployment. If I don't put that in there, it will automatically deploy. That's perfectly fine. And I'm configuring this in no cluster mode so that it doesn't spend extra resources trying to set up a cluster. Otherwise, it will try to do so, and it will extend the deployment. So, OK, Docker desktop is running. Let me start, not that one. OK, this one. So let me kill this. And there we go. Let me start this. So how do I test my container? And in this particular case, this method, this might not be necessarily something that people do in the real world, but I like to show it because it's important. The test container, as you can see, is a static field. Test containers works in this way. If your container is an instance field, for every test, it will create a separate instance of that container. So if you have 10 test methods in this class, then it will create 10 separate containers. That is overkill for the purpose of this test. If you declare that field as a static field, for that test suite, it will create only one container, start it at the beginning of the test, use it for every test method defined in there, and kill it at the end of that test suite. So that's what I'm doing. And I'm using and showcasing JUnit 5 and running all of my tests in order. You can see here that first I add a speaker. Then after adding a speaker, I get this data. Then I check if it exists. Then I check that another speaker doesn't exist. These are the basic tests that I run. And all of these tests are in order. As you can see, the first one runs, then the second one, and the final two tests are actually having the same order, so I don't care which one is executed first because those two run in parallel. How am I executing my test? I'm using REST Assure. This is a nice REST testing library that was created for the test development driven paradigm. It uses a given when, then methodology. So you create a context, give it data, and expect something. So adding a speaker is just simply, oh, I'm creating a new speaker, my name, it works for Payara. Then I simply execute a post request to this endpoint or this path, and then I want to see, did I get a 201? and it's the location of this resource, speaker 1. Speaker 1, why? Because this is a exactly controlled data vision of what I'm expecting. Since the container is fairly new and the database is fairly new, the first speaker will always be the one, unless I'm doing some crazy shenanigans on my database setup. But that's how it should work. And that's what my test should return. The get speaker will simply, based on that premise, try to get the data from there, and the check speaker method will use the head method of the HTTP head method to make sure that I am getting the data that I need. You can also see that I'm using Java code. I'm not creating JSON from scratch. This is nice because, again, this is testing. So I can use any, in this case, for this particular project, I think I'm using JSON. In this case, I think I'm using, yes, I'm using the JSON specification. This is basically JSON with another name. It's just serializing and deserializing Java to JSON and vice versa. And I'm using that in order to use my POJOs instead of creating JSON objects. Because again, this is testing. I want it to be simple. So you can see here that it should have run the test. You can see everything is green. What do I see when test container does this? You can see that the Docker environment is prepared. It will give me the server version of the Docker container that I'm running, the API version. It will create a container at the beginning, and it will create a container using something Ryuk. This is a technology that test container uses to manage containers themselves, and it's a container, dog fooding. And then it will start the container. It will tell me, oh, I'm waiting for the URL that you provided me to be ready, and then I will execute the test when the container is ready. Everything in here will always be printed when you run your test containers. Pretty simple to do. Now, let's see the session service test. I need two services in here, remember. This one depends on the speaker. So I'm creating two containers. One for the speaker, one for the session. They work exactly the same, but with some added extras. First, remember, I have to create a network to put my containers in there. So what I'm doing is putting the session service in the same network as the speaker service. And for the speaker service, I'm giving it an alias, name speaker, pretty simple. And then when I create my session service, remember, they know where they are, but now I have to specify the location of my services. This and this application uses a specific technology called microprofile REST client in order to locate external REST services. And in order to do that location, you have to provide this standard microprofile property, which is just the name, qualified name of the interface of that service, /mprest/URL, and I have to provide a URL. And what is the URL? Speaker at port 8080. I know that is fixed because that is the alias my container knows. On a production system, that is an environmental variable that will be provided by, let's say, configuration registry, or a Kubernetes secret, or a Kubernetes configuration directory, or what you want to call it. Or if you're passing that variable over the command line, that's one way to do that in production as well, but that's an option. But for the test, I don't care. I just simply want to call this service. And as you can see in here, everything is set up exactly in the same way. I pass over the WAR file, deploy it, wait for 200 on this application WADL endpoint, and then I run my tests. On my test in this case, what I want to do is before I run my test, I want to create a sample speaker. And then once that speaker is created, I will add one session, exactly the same thing. I'm using rest assured to make sure that all of my data is in place. Then I will add a second session with specific additional parameters, make sure that I have the session or the data for the first session that I created, and the data is equal to what I created. So this is important. Remember, the entire point of creating tests in this way is making sure that the integrity of the data is exactly as you expected. And I am also checking some extra things. I'm checking that a session that I created doesn't exist, so I want to see, oh, does 100 section exist? It doesn't, because my tests aren't creating that. And I can also test that I deleted all my sessions. So let me run this quickly. So again, be patient because my machine is not that powerful. It's probably choking up with now 2 containers at the same time because it requires extra resources, but you can see now that it's running. It does it faster as long as if your local Docker registry has all the images in place, it will run much faster because it doesn't have to pull them up from Docker Hub in this place. As you can see, it's waiting for the first container to be ready, and then it will print out all of the data that you need in a bit. Now it's starting the second container. You can see that the first one has started. Now it has started the second one. Let's give it a bit more. Here, rabbit. And then, well, it's still running. Again, my machine is not that powerful. You can see that it started, and now we'll start running my tests once the container is done. This showcases that, yes, it is an excellent technology, but it's resource intensive. But all tests green, everything is good. Now, for the final service, remember, my boat service depends on a database. So I'm creating a MySQL container in here. You can see it. And this SQL container simply exists on a network. I'm using MySQL 8, and I'm giving it an alias. I don't care about anything else. I'm not providing extra parameters to that container. Let me minimize this to give more space. And I'm creating a speaker service container, a session service container, and my boat service container. And this one, it's, let's say, bulkier because it contains the configuration for my database. Remember, my database is configured using environmental variables on the data source definition. So I'm passing those parameters in here. I'm creating the JDBC URL, getting the name of the database from the container. I'm extracting the username and the password for the default root user of that MySQL database. And that's it. That's how I connect the database itself with the extra services. And everything else is additionally what I show you. I have to copy the container, the WAR file to the container. I also have to copy the MySQL JDBC jar file to my container with the application running, because with that one, I wouldn't work. I can ship it as part of the WAR file, but I just wanted to showcase that if you're not doing that, you have to provide the jar file to the container itself, because otherwise it won't connect. And for this case, this test will probably kill my machine. We'll use Testcontainers Cloud. So let me kill it. And the beauty of Testcontainers Cloud is that you outsource tests. Technically, you will be running your containers on a service cloud that will get your request. It will spawn the containers for you, will run the test, and it will kill the container. So it's literally testing on demand. And to do so, I will start the agent for Testcontainers Cloud. This literally immediately starts. You can see this in here, and I will run my test again. Well, first time, because this is a boat service test. So I will run it, and again, it has to compile everything. This is what we're talking about. So let's give it a second. Okay, now it's running, and now it should run much faster because it's not depending on my machine. It's just simply executing the test remotely. You can see now that it has started. It's pulling the images. It has created the first one. It's creating the second one. It's creating now the database. It's creating the third one, I think. Yeah, the second one, the third one. Okay, it was creating the database at first. It should be ready in a second now. And if you can see in here, when the Testcontainers engine is starting, it uses Testcontainers Cloud. And the specific version that they're running at the moment, which is version 70, everything should be set up. And now test should be running green in a few seconds, a bit, because network is a bit slow. That's the other problem at the moment with this Wi-Fi that we're having. Come on, why are you so slow? Zoom in. Yeah, the network is sabotaging me, and tests are coming green now, and everything passed. Much faster. If I try to run this test, it will probably kill my machine. I tested it an hour ago, and the third one ran literally 2 containers. The third one literally killed resources, and Docker just simply exited. But again, this is a cheap laptop. It doesn't have that much power. But you can see that it works exactly okay. If you do not want to use Testcontainers Cloud, you can technically do this by putting this test on a CI/CD pipeline, running on Jenkins, spawn the instances on a cloud or an on-premises system that you have created, run the test, kill everything, there you go. And Testcontainers also has CI and CD integration. I don't have time to showcase it, but they have really good instructions on how to do this. And you can even run Testcontainers Cloud with CI/CD. So that's something to look forward to. So in summary, Testcontainers ease up writing tests, simplify dependency management. You don't have to create. Nowhere here I have installed MySQL, don't have installed anything. Everything runs in Docker. Nothing else is on this machine. Allow real-world testing. I tested a MySQL database in real time, and it didn't see anything. I didn't see data. I didn't go in there and run any MySQL commands. I trust that everything there runs okay. Makes true portability a priority, because this application, now that it has been tested, should run okay in production 99.9999% of the time, but that's one, and gives enterprise Java and a vendor-agnostic framework for proper integration testing, which is something that we lack. I like because it's pretty simple to use. Its learning curve is especially small. If you already know Docker, you should know this in literally a day. It's not difficult. So, questions? Yeah?
So after you build, it's created an image and then that gets uploaded to the cloud?
Yeah. No, the image is not up. Well, yes, it's uploaded to the cloud. If you're running the Docker image, in this case, remember that I'm running images that are on Docker Hub. All Payara micro images are on Docker Hub. The MySQL container image is in Docker Hub. So technically, I'm not uploading anything. I'm just simply grabbing everything from Docker Hub. The only thing that I'm sending Testcontainers Cloud are the tests themselves, the Java source files, technically. Well, the binaries in this case. And it's executing them remotely and giving you back data. You think that Testcontainers Cloud doesn't support personalized registries for custom Docker images? That's something that you may want to talk to Oleg about. If they are supporting that in the future, he's not paying attention, but he'll probably have an answer.
Registries? Yeah.
Okay, he's saying yes, so I'm assuming that's supported.
And then your IDE has a plugin that has the credentials for the cloud?
It's an agent that you install on Windows. This an application at the moment is on private beta. You can request an invitation. You install it. Once you open it, you will provide credentials to your account and you will set it up. And see that in order to run it, I had to kill my Docker local installation, because otherwise it would use that. It will try to find a Docker agent running locally. It will find technically the Testcontainers agent cloud. It's an interceptor of a Docker, process instance. So, there is a Docker engine running in here, and it'll technically mask everything and run the request remotely for you. Any additional questions? Yeah?
Does it require Docker and Docker to be set up if your pipeline is in Docker itself?
I assume not. I'll have to test it. I haven't tested it like that, but I would assume not. That it would be perfectly okay using that Docker setup. Okay? Any additional? Yeah?
You have built 2 web servers, right? So one is speaker and another.
3 technically. Yeah.
Where do you host it? You build the WAR file and you run it locally, and the rest assured is not running your web service, right?
No, none of this is running locally. It's on Docker. Well, when I run Docker locally, technically, yes, that was locally. Now this one, which is on the cloud, it's
the WAR file to the cloud?
It sends all the binaries, because the file itself, the test itself, let me show you here. It grabs a WAR file in this instruction for the Docker with the copy file to container. So technically, remember what I said, this is a Docker CP command. The API translates that to a Docker CP command, and it brings the WAR file over to the cloud as well.
So the WAR file is already generated, kept in your local?
Yeah. Yeah, and again, I did that for simplification. I didn't want to build everything, just simply assuming the WAR files are in there. But that's it. The project setup is simple. Every WAR file is generated. Let me quickly show you here on the POM file.
So we can generate it through the POM file on the Maven command?
Absolutely. You can use dependencies plugin in order to pass the WAR files. You can use the one that I'm using here. I think I'm using dependencies. I wrote this a long time ago, so I don't remember.
Via IntelliJ, when it comes for the Jenkins build, it has to be triggered via Maven, Gradle plugin.
Yeah.
So do you support any Testcontainers? Does it support any Gradle plugin?
Now, these tests don't, again, because I didn't have enough time to test CI and CD, but you can do that perfectly. You can create your Jenkins, or you can configure your Jenkins pipeline in order to build a WAR file from the source code, pass it over to your tests like that, and run it over again.
In local, I'm asking. In local, you're generating, you're running this test with the already created WAR file.
Yeah.
So if you have to integrate it as part of my build process, like the Maven build, when you generate a Maven WAR,
Yeah.
then is there a way we can add as a task, Maven task, and start up this container?
Yeah, that's exactly what I'm doing. What I'm doing here, it's generated the WAR files in here. You can see that I'm using the, I'm trying to remember, I can't remember whether I put that setup. I think it's on the parent project. With the dependency, now it should be on every POM file separately. I'm absolutely sure that it should be copying over the WAR files to the location of the combined test module, because that's a separate module that I'm using. But yeah, I don't remember where I put that, but technically you should be able to do so simply with using Maven. It's just simply passing the WAR file to a location with the copy file to container. Again, this is because Payara Micro works this way, but you can simplify that. If you use a technology that can just simply pass over the WAR file in a simplified manner, that's good. Or you can grab it from a local registry, which is also an option. But again, all of this is Maven and Docker, so it's doable. Any final questions?
Does it work with Podman?
Yeah.
Podman?
Yeah, absolutely. But Kubernetes testing, it's a bit more complicated. Technically, you would get to that point after running integration tests, is what I would say, because Kubernetes is infrastructure itself. But you can do localized cluster tests on Kubernetes, absolutely, if that is something that you would like to do. I think that Docker container, I think that Testcontainers, I show you a compose example. You can go in that route and also use it for Docker Swarm or maybe for Kubernetes as well. Okay, so we run out of time. Thank you for coming to my talk.